Hi everyone, today our group will be conducting our experiment for our project entitled The Use of Bernoulli Equation in Determining Velocity and Pressure Change in Regulating Hose Water by using a thumb technique. Our experiments only required two simple equipment, which are a water hose and the next one are the water pipe for the source of water. Alright, so let's jump to the experiment. So in this experiment, we will be using three different techniques. So the first one, we use the 1/4 thumb techniques, which means we close the quarter of the water exit area. And the second one, we will be using the half thumb technique, which means we close half of the water exit area. And the last one, we use the 3/4 thumb techniques, which means we close the 3/4 the water exit area. Since we are doing an experiment on a Bernoulli's equation, it must have a pressure, right? But since we are not having a special equipment for measuring pressure, such as a pressure gauge or a manometer, so in this experiment, we'll only be assuming that the pressure is constant throughout the experiment. Okay, so for the first one, we will be doing the quarter thumb technique. So let us observe the change in the water flow after we apply this technique. Okay, so this is the quarter thumb technique. Spot the difference, right? Okay. So the next one is the half thumb technique. So I'll be close half of the water exit area. The speed of the water increases. Okay, and for the last technique, which is the 3/4 thumb technique. And we can see the difference, and that's when the Bernoulli equation is applied to this experiment. So I guess that's the end of our mini experiment for our group project, and the outcomes and the calculation for our experiment will be discussed next in our slide.
So for the description, there is a problem that we need to overcome, which is the water could not reach near the plants and pots. So it's difficult to control the flow of water for watering process, and also it too much water flow out from the hose. So the solution to overcome the problem is use the learn the thumb technique, which is there are three, which is 1/4 technique, 1/2 technique, and also 3/4 technique. Okay, as for the analysis, we know that the Bernoulli's principle states that the total mechanical energy of the moving fluid comprising the gravitational potential energy of the elevation. So the energy associated with the fluid pressure and the kinetic energy of the fluid motion. So it remains constant. Bernoulli equation formula is a relation between pressure, kinetic energy, and gravitational potential energy of a fluid in a container, where P is the pressure exerted by the fluid, V is the velocity of the fluid, and rho is the density of the fluid, and H is the height of the container. Then Bernoulli's equation gives great insight into the balance between pressure, velocity, and elevation.
For the calculation part, it includes 9 steps of it. First is step 1 is convert pressure to pascals. Step 2 is calculate internal diameter. Step 3 is calculate cross-sectional area. Step 4, calculate the effective area. Step 5, calculate the average pressure. Step 6, using Bernoulli's equation for the velocity of water inside the hose. Step 7, calculate the velocity of water exiting the hose. Step 8, calculate the pressure of water exiting the hose. And the last step is calculate the height difference. So that's all for the calculation.
So we had come out with a conclusion. We have concluded that these manual pressure regulating hoses are essential and important equipment for a wide range of sector and users. This combination of robustness, adaptability, and affordability allows them to facilitate effective operations in challenging environments. Their capacity to deliver accurate pressure controls make them indispensable in fields such as construction, industry, and also agriculture, where dependable fluid or gas management is necessary to get accurate and best result.